I'll just wait a moment for people to pour in. Welcome to the Interplanetary Project Transmission, and we'll just wait a few minutes for more people to come into the meeting. All right, fantastic. I think we should get going. Thanks so much for coming to join us. I see lots of familiar names out there. This is our meeting where we give updates on how all our projects are going and what's happening with Interplanetary Initiative. And we follow this motto we have that everyone is invited all the time. So we're really glad to see you. If we could have the next slide. Some things that are good to know, otherwise known as housekeeping. Today's presentation is in a Zoom webinar format, and so attendees are not seen and are muted by default. So during the Q&A, please submit questions using the Q&A button. Questions sent through chat will not be seen by the presenters, so don't forget to use the Q&A button. For best viewing, you can switch to Fit to Window in the upper right-hand corner of the video screen, and all attendees will receive the webinar recording and survey after the event. Go to the next slide for the agenda. So we're going to talk a little bit about welcoming what's new like we usually do. We'll have an update from the Interplanetary Lab and some updates on our exciting industry alliance, which we're really excited about actually. And then the classic updates from our pilot projects. And I also want to add at this moment that I'm very happy to be with you for about the next 10 minutes. And then I actually have to go to a Psyche mission scheduling meeting that's been called that I have to attend. And if I possibly can, I will be back. My heart will be with you and I'll watch the recording for the bits that I miss. All right, on to the next. Welcome to everyone and meet our new team members. So we have Joe Dubois, who's a senior engineer for special projects. He's working with the lab and with industry partners. Sally Young, who's a senior communications specialist with tremendous experience in the news industry, and she's been writing our press release stories recently. Great job. Alicia Hayden, our academic success advising coordinator, who is directly supporting our students who are in the technological leadership program. And Kenny DeGordine, who's just joined us as a student worker, and she's learning parts of all that we do and already becoming an invaluable part of the team. So welcome to our new team members. Now, some educational program updates. I'm very excited to talk about our Open Citizen Gathering. If you were with us in the spring, then you learned that we are launching this new program called Open Citizen, which is a structure and a program that allows groups of people, particularly community-based groups of people, to choose a project or a topic that they really want to make a difference in, or that they want to learn about or create within. And it gives the structure to actually conduct that entire process for a group. And so it's really about community-based change making, but also about individual learning or the project of your choice. So we had a great big gathering at Arco Santi in November, and we had about 70 people from many different community-based change maker groups and people who just wanted to learn about the process. And it exceeded my expectations. It was really great. And we've got quite a number of groups who are actually starting to use the process already. And it's available for high schools or after school libraries within corporate environments. And so if you have interest, be in touch. But it was a great launch. It was very exciting to have a launch that was that good. And for a lot of us, it was our first real face-to-face event. And that was wonderful to be three-dimensional humans again. All right. And then our technological leadership undergraduate degree, we launched during COVID. We've just finished our third semester. And because we have a number of transfer students in the degree, we're actually having our very first graduate this semester. Student, yay, I know, Parker Cohen-Sit is graduating this semester. We're very excited. And wanted to show some of the design, making, inquiry style courses that are being offered in the spring in case you or someone you know is a student at ASU. So Creative Future Studio, this is something that Phil has been teaching from its initiation. He's waving there, and that, oh my gosh, I'm really proud of this class. It's really great what you've done. It's all about giving the power to the students to figure out how to run their own projects and make up their own course. And it's been running extremely well. I was really happy to see some of the final presentations. So that'll be happening. Designing and Making for an Interplanetary Future. This is our most audacious course. This is a maker course. Learn how to make things with your hands in an engineering sense, thinking about things like social needs and ethics. And it's actually taught entirely online. And so students receive a package, a maker package, which allows them to learn. And that is taught by Eric Stribling, and that'll be happening in the spring for its second time through. Then the third one, Inquiry, Does Life Get Started in Hot Water? This is one of our classic inquiry courses. This can be taught by my colleague and great friend, Everett Schock, who's one of the experts in astrobiology, geochemistry, how life interacts with planets, world-class expert. And the question, the big question that they're asking for the whole semester, they'll be doing research to understand is, does life get started in hot water? In other words, do you need a hot spring or a hot smoker at the bottom of an ocean? How does life get started? So that is, I can guarantee that it's going to be very interesting. And finally, astrobiological arts. This is a twist on the inquiry process that Lance Garavi, who's one of our associate directors and a professor of theater, and Patrick Young, who's professor in the School of Earth and Space Exploration and an astronomer, have put together that combines art and science in an inquiry course so that students learn about astrobiology as they go. So these are just courses in the model of what we're trying to do around exploration learning that we wanted to share that are being offered in the spring. All right, onward to our research and innovation updates. So research and innovation broadly, and might include the Interplanetary Lab, which Danny Jacobs, our Associate Director for the lab, is going to give you an update. Industry Alliance, which Jessica Rousset is spearheading the process of that. She'll give you an update. And of course, the pilot projects that are the real main meat of this meeting. And also our new Interplanetary Fellowship, which I'll speak about briefly. But first, a really exciting new partnership that we were really thrilled to get going. The Orbital Reef Low Earth Orbit Crewed Space Station concept, being led by Blue Origin and Sierra Space, Boeing, Redwire, Genesis Engineering, and us. So we are the lead of the University Advisory Council, and our job with this fantastic group of 14 universities is to do three main things. The first one is to create a set of research ethics guidelines to make sure that whatever research goes on Orbital Reef is correct. The second one is to form an expert group for users who want to learn more about how to do this. Among these 14 universities, we really have experts in anything that a partner might need. So whether the partner is coming to make a film, open a space hotel, or do a bunch of cutting edge pharmacology research or materials research, there'll be somebody at these 14 universities who can help them with what they need to operate in low Earth orbit. And then finally, the third part of our remit as the University Advisory Council is to lead in the education and public outreach. And so this is really, really exciting thing to be working on. I think the work we're going to do is going to go far beyond the effects of Orbital Reef itself. But Orbital Reef has just been selected by NASA, got a $130 million planning grant, and are expecting to have a minimal Orbital Reef configuration up before the end of the decade. And so we are hoping to be a big part here at ASU, Interplanetary, and our 14 partners of helping to make space more accessible for everyone who wants to experience it. So that's our exciting new partnership, now funded. Finally, Interplanetary Initiative, before I pass it off to partners here. We had this idea of a fellowship, wanting to bring in more people from around the world to interact with us and bring their special knowledge, because of course what we're trying to do here is bring together all different disciplines to think about positive human space futures. So we need philosophers, we need people who are experts in religion, we need artists and lawyers and policymakers and everyone you can imagine. So Sona Seeley, who's on our team, did an amazing review of all the fellowship programs at American universities she could find, all the different aspects of them. And then she proposed to us the best format for our Interplanetary Fellowship. And then we actually advertised it. And I'm so happy to introduce you all to Theodora Ogden, who is our very first Interplanetary Fellow. So Theodora, feel free to unmute and spend a couple moments introducing yourself.
Hi everyone. Apologies, my camera doesn't seem to be working. It worked, albeit slightly briefly, but such is the way of technology. So yeah, my name is Theodora. I am from the UK, as you can probably tell, London specifically. In my day job, I am based at RAND Europe, the smaller European cousin of the RAND Corporation in the US. I work as an analyst in the Defence, Security and Infrastructure Research team. And prior to RAND, I worked in the Office of the Legal Advisor at NATO HQ SACT. So I come from a background in international law, security and emerging tech with a focus in space. We've recently done a lot of work for the UK Space Command and the UK Space Agency, where we provide insight into space strategy and are supporting the budding UK space sector with our research and policy recommendations. So I have an interest in untangling some of the high-level problems that we are facing in the space domain. So particularly regarding orbital congestion and new players in the domain, both in terms of private actors and states. So I'm really interested in some of the questions that remain around international space law, the Outer Space Treaty, and the right for everyone in the international community to access and explore space. I'll be looking at some of the benefits that such new actors could bring in terms of research, collaboration, and innovation, as well as some of the emerging challenges and risks. So the research project I'll be working on during my time at the Interplanetary Initiative involves a detailed overview of the state of emerging space industries and economies, which I'll be providing via a series of country-specific case studies, as well as literature review and analysis and interviews with space experts from both sides of the pond. So I'll be teasing out some of the core lessons that we can learn when it comes to standing up space agencies, establishing space priorities, and navigating the own collaborate access minefield, as well as building up sustainable space industry. I'm really excited to be joining and look forward to meeting you all and tapping into your space knowledge and experience. Many thanks for the warm welcome, and I look forward to being in Arizona in person and escaping England's terrible winter weather. Please don't hesitate to reach out to me, and I look forward to touching base.
Wonderful.
Over and out.
Thank you. Yes, Theodora will be joining us in person starting in January. And so if you would like to meet with her, propose projects, have her join a class, let us know. Sona Seeley's point of contact, or Theodora herself, and we welcome all kinds of connections. That's the goal. Well, with many thanks, friends and colleagues, I have to step off to my Psyche meeting, and I'm going to turn this over to Danny Jacobs to talk about the Interplanetary Lab, and I will rejoin if I possibly can. Thanks so much.
Thanks, Lindy. So I'm going to give you, if you don't already know me, I'm Danny Jacobs. I'm a professor at the School of Earth and Space Exploration and an assistant director at the initiative, and director of the lab, where we're doing lots of stuff. More than we can possibly tell you about today in the time we have, but I do encourage you to look us up online and get in touch. I'll give you a quick overview of the lab, just to, if you don't already know about it, and then hand it over to a couple of the student staff who are going to tell you about some more of the projects that we're working on. Here you can see just a sort of collection of some of the things that we do in the lab. I'll tell you about more of them as we go. Go ahead, Matthew. So the mission of the lab is to kind of be an enabling glue across campus and with partners outside campus in this sort of area of space hardware, specifically smaller types of things, but also just more generally to sort of do projects that are relevant to things going on across the initiative, everything from education to and outreach to sort of more exotic things like art projects. But we're a physical manifestation of the Interplanetary Initiative on campus. Go on to the next one. So like I said, we do things, since we have a people that do things, specifically a staff, student staff, who are all engineering or related fields, but broadly speaking, they enable what we do in the lab. They actually do stuff, and we have a range of specialties from electrical and mechanical and aerospace and a lot of other things. And here they are down here. Specifically, you'll be hearing from Matthew there on the left and Ashley there. So the lab itself is about 6,000 square feet of space that's been carved out of an old gymnasium on the Tempe campus, not far from the Student Union building. So it's right in the middle of campus. It's in this really cool space, and it's all brand new. It opened in February of 2020. And it is sort of, I like to call it a space maker space. It's available to registered users, who could be anybody, literally anybody, students, faculty, outside partners, you name it. Keep on going. We have, go to the next one. Yeah, so we have we have a bunch of different kinds of space. We have sort of a general hacking hangout space, which has movable tables and just lots of area for students to do what they need to do, homework, whatever. There's also a lot of other stuff to make work and just hanging out a little bit easier. There's an electronics lab, which is set up for basically rapid prototyping, but also building actual flight hardware. So we have everything from 3D printers to reflow ovens and things like that. So you can actually make boards. And all this stuff is reservable by users, so that we can keep track of what we're doing and collaborate on stuff. Keep going. We also have a sort of more of a flex lab that we use for testing and a lot of and fabrication. So we have quite a lot of space for permanent fixtures, like some of them will show up later. But you can see there's quite a lot going on in there. Keep going. So one of the things we'll tell you about are some of our project internal sort of facilities developments. But first, I think some of the things that I just showed you in that picture there, like we have a vibe table and a vacuum chamber. But we'll potentially come back to those if we have time at the end. But for now, I think I'll hand it over to whoever's going to talk next. I think it's Matthew. Yeah, go ahead, Matthew.
Thank you, Danny. So we had some projects, some ongoing currently and some that have completed this semester. We have ExoCam, which is, we'll get into it more detailed, but essentially it's a camera that will drop off of a rocket lander and provide a unique perspective of video capture for landing. We have a light cube. It's a small satellite CubeSat, for those of you familiar with the term, that will be able to will be open for operation by anybody on the ground. And then we also have Dora, which is a slightly bigger CubeSat, and we'll talk about that a little bit more too as well. And it will have, it's for laser optical communication. So getting into ExoCam, what you can see in the kind of the poster-ish photo, it's basically you have this rocket and that's from Maston Space Systems. And we have this wireframe ball thing attached to it. So as you land on the surface of like another planet, the ball will eject, fall to the ground, sit inside the cloud of dust that's being kicked up by the rocket exhaust, and then you'll capture video as the rocket comes down. But we also, ASU developed in the lab a sensor package that attaches to it to measure kind of what's going on inside that plume of dust and particles. So if you look on the right, you can kind of see the wireframe ball that was actually used. And then all those little discs you can see are actual piezo sensors that we use to measure like a particle flux. And then some of the partners we had was Masson did the rocket, of course, and then Zandef Deskit, they kind of quarterbacked and were the ideas behind the whole thing. And then Honeybee Robotics built the actual hardware that you see, that wireframe and that the camera housing. And then just like a quick time frame for everybody. It was May, we kicked the project off with Zandoff Deskit, and then June, July, we were prototyping, revisions, and continued prototyping. And then in August, we had to assemble 5 of them for use. And then we shipped them out to Honeybee. And then in September, we went out to Honeybee, which is in Pasadena, California. And then we assembled it onto the device. And then October, we went for the flight. And then on the top, you can just see that's me excited after a successful test off of a bridge. And then Christopher, one of the other lifeguards working. And then the both of us with the rocket, actual rocket in the background after the test that day, which is a really, really great day to see everything that happened during flight.
Right, now on to another project, this one ongoing, LightCube. So LightCube, as we said before, is a 1U CubeSat, 1U meaning it's 10 centimeters by 10 centimeters by 10 centimeters, so it's very, very small. And the goal of LightCube, or the mission of LightCube, is focusing on educational outreach, specifically making space more accessible to people of really all ages. And essentially with LightCube launched in the sky, the whole idea is that people on Earth are able to, with a simple radio, trigger a flash bulb on the CubeSat. And if they do it at the right time, they'll be able to actually see the flash from the CubeSat as it orbits overhead. And so this is a really, really cool project because it allows or gives people the opportunity to interact with something from space with one of their 5 senses. Now, in regards to partners for NASA, LightCube will be sent up to the International Space Station for deployments. We are also partnered with NASA CSLI, which is short for CubeSat Launch Initiative. And this is a program that helps student-led projects to launch their CubeSats for free. And so our project in particular was accepted in May 2021. NanoRacks is an organization that's helping us to interface with NASA. We also work with a capstone group from ASU's Electrical Engineering College, and they're working on the power systems of LightCube. Additionally, we also work with Dr. Michael Gorel, who's been working on the payload side of things. And aside from ASU, we've been working with another capstone group from Cetus Universidad, which is a university located in Mexicali, Mexico. And they have been working on developing the antenna for this project as well as for DORA. And then lastly, for Vega Space Systems, this organization was actually founded by Jaime Sanchez de la Vega, who previously worked at the II Lab, and LightCube actually originated from Jaime. And along with being the project lead of LightCube, Jaime is also leading the Cetus capstone team. And then finally, we are planning to deliver LightCube to NanoRacks, who again is our launch provider, in March of 2022. Now, aside from working on LightCube, DORA, ExoCam, we also have a couple projects focused on improving the lab's capabilities, which includes our thermal vacuum chamber, the TVAC, our vibe table, and our ground station.
So the thermal vacuum chamber, just for those of you who don't know, when you go to space, you're in you're in vacuum. And so anything with like an air pocket can basically blow up like a balloon. And you don't want that when you just spent a lot of money trying to get up there. So what we've been doing is we've gotten a vacuum chamber from another building, on campus, and we've been refitting it with upgrading seals, ports, anything surrounding it to give it more capability. We've been adding electrical feed-throughs. We're also going to add some heating capabilities and cooling capabilities. That'd be like the center photo if you can see that. Those are heaters, and then that'll go in. And so we're building that up as we go along and building our capabilities. And then on the right is just a team from CC, School of Earth and Space Exploration. They needed a low pressure atmosphere replication. So we were able to provide that. And we've provided for a couple of teams in the vacuum chamber as we've been able to upgrade it, which has been really great.
Now, another bit of equipment that we have is a vibe table, and a vibe table basically shakes whatever is set onto it to ensure that that object can withstand the shaking that comes with like riding on a rocket. And so what's really nice about having our own vibe table is that firstly, it's a lot cheaper than going to outside suppliers and strapping our tiny CubeSats onto the giant vibe tables that they have. Secondly, it's also a bit quicker and easier to use because it's so small. And recently, something that's made it even easier to conduct tests, or will make it a lot easier to conduct tests, is our new test fixture, which is shown in those 3 pictures. And so this fixture can hold from 1U to 3U CubeSats without worrying too much about how much the CubeSat weighs. And then with a little more care, we can hold up to 6U CubeSats. And so the picture on the right shows a model of a 3U CubeSat being held in this fixture. And so we've used this VIA table to test the package sensors or the package sensor for ExoCam, but rather than being restricted to use by just the lab staff, users can come in and also vibe their own projects and tools as long as it's under our supervision. And then the last bit of equipment that we'll go over is our ground station, which of course allows us to communicate with satellites, right? So this ground station originated from the SDSL Phoenix satellite team, who originally created this ground station to communicate with the CubeSat that they are developing, which was called Phoenix. But now the lab has taken to this ground station and are in the process of fixing it up so that we can use it for our own purposes. And so our current goals include establishing regular contact with Phoenix again, establishing contact with another CubeSat, Qt, which was developed by students at University of Colorado Boulder and a couple other satellites.
Just so we've been having people come in, use the lab. That's like, as Danny said, we want to be the glue for all the people coming in. So just some statistics. In recent time, since November, we've had more than 36 user visits. And just so you're aware, user is basically anybody that we've trained as lifeguards to come in and use the equipment themselves, like soldering or using some of the other equipment under our supervision. And then since May, we've had over 500 visitors. These would be people who are just touring to see what we offer, whether it's students from that are prospective students, or so I know Lindy had brought in some of the Psyche team. And then we've also had 4 customer projects since May, and then we have 6 active projects. So we're always busy here at the lab working on something. And then actually the most prominent visitors we've had, we actually played host in the lab to the Ascend in Space grant. So Ascend is basically a program in Arizona where they build a payload with several sensors and devices and a camera, and it goes up on a balloon, and then you have to go chase it down after the balloon pops. So actually the ASU Ascend team needed a place to work, to host meetings, build their equipment, test their equipment. So we played host to them and all of their equipment, and then also offered advice whenever we could on sensor development. And then I think it's a cool photo. You can see at about 100,000 feet, the blue of the Earth. So that's about all we had. So if anybody has any questions, we'd be happy to answer them.
Awesome. Thank you guys so much. I'm Jessica Rousset, the Deputy Director here at the Interplanetary Initiative. Thank you all for joining. And there is one question for you, Matthew. How does the ExoCam camera aim at the lander?
That is actually a great question. It is actually, if you don't mind me, hopefully this isn't too much to see. It's actually a GoPro Max 360 camera. So when it lands, it doesn't have to worry about orientation. It will always have a 360 view. And it's a really good stitching program that lets you put all the orientations together. So it's actually a really good, pretty good shot.
Thank you so much, Matthew. And thank you guys for that presentation. There are no more questions at the moment. So I'm going to take over for just a few minutes to talk a little bit about the Industry Alliance program, which is a brand new program that we are just launching and we're very excited about sharing with you today. So a little bit about the program. So what the Alliance does is it engages companies from startups to larger private sector companies that are either actively engaged in the space industry or perhaps seeking to enter the market segment. So by companies joining the Alliance, they'll have not only the opportunity certainly to connect with other members, but also to access the programs and the people across ASU to advance their business goals. And so opportunities range from workforce development, product development, and business development. And we've designed this program really recognizing that, of course, all companies have their own unique sets of priorities and goals. So we've developed a menu of benefits, which I'm not going to go over with you today, but that can be accessed in different ways. They can be accessed on an annual basis by becoming an annual member, and we have different tiers of membership, as you can see here. The one common theme that I do want to draw your attention to is access to the Interplanetary Lab that you just learned about. However, You can also access these benefits more a la carte, so we can sort of tailor a package and a program that makes the most sense for your company to add the most value. And if you're interested in learning more, and also we're just launching this, so I just want to also share that we are sort of co-creating with our members. So if there are aspects that are more valuable or things that you'd like to see, we are sort of designing this really to generate the most value to our members. And then the last thing I will say as well for access to the lab is that it is set up as a recharge center or core facility, meaning that it's sort of a fee-for-service model, making the access very easy, and it's very easy to do business and to come into the lab and work with us. So yes, to answer the question that just popped up, what's the procedure for partnership if anybody needed to partner with you, who would be the contact? So for the Alliance program specifically, you can reach out to me. My information is here on the slide, or you can reach out to Joe Dubois, our lead engineer in the lab. And you can also reach out to Joe if you're a student or faculty member, if you're interested in accessing the lab. You can reach out to Joe or Danny or any of the lifeguards. All right, I think those are all the questions there. And so I'm going to move on to the pièce de résistance here, which are the pilot projects. And to get us, just to introduce these, we're going to hear, well, first we're excited to hear about 2 projects that we've been supporting for a few years. And we have 3 brand new projects that we'll be introducing to you today. But briefly, I want to share with you the unique way in which we launch and seed fund these projects. All of these are born from a facilitated, there we go, a facilitated teaming process that centers on big questions that get brainstormed by workshop attendees. So these workshops are intentionally designed to be open to all types of participants with a range of both life experiences and professional skill sets. So students, faculty, staff, industry professionals, and members of the general public all are invited to participate at these workshops. So this year, the overarching theme of our Big Questions Teaming workshop was, how do we increase the participation of nations and groups who do not currently have strong accessibility to space? And so today you'll hear from 3 projects that will address this theme by asking vastly different questions. And I think that's what makes this process so compelling. So first, presenting for Earth Operations Center project, which is one of our projects that we're continuing to support, is Jake Pinholster. And I am going to do a brief introductions for anyone who's joining that might not be familiar with our teams. And so Jake is the team lead for this project. He's Associate Dean for Enterprise Design and Operations in the Herberger Institute and Head of Graduate Programs in Interdisciplinary Digital Media and Performance Design. He's also the founding director of ASU at Mesa City Center. And so Jake, thanks so much for joining and telling us about your project, and you may take the floor.
Thank you so much, Jessica. I'm just gonna quickly share screen here. Whoop, nope, not that one. It shifted on me. Here we go. Everybody see the Earth Operations Center screen? Yes. Okay. So yeah, we're like in our 3rd year of the Earth Operations Center, or just entering our 3rd year. We've been it's been a fun project to do during COVID. It's certainly been changed the direction, I think, in some ways of what we've been trying to accomplish. But the Earth Operations Center is based on, we originated in its Big Questions meeting about how do we galvanize public and private support of space exploration. And largely this is by helping us understand our own planet better and helping us understand the way we can think about and manage planetary systems, and the way space and managing climate's crisis, climate change are kind of intertwined. So we're essentially creating both physical and virtual mission control spaces focused on planetary systems that are for public communication of science, for informing and assisting policymakers and decision makers with emergency management to long-term strategic planning. And then also as a kind of effective scenography, this is part of where I come in, like the notion of being able to inspire people with the notion of being able to see kind of the complexity of the Earth systems all in one place at one time. So the two sort of formal goals are the enabling of new insights into the nature and progress of climate change through multidisciplinary syncretic collaboration and the ability to communicate those insights to critical stakeholders. But I have been thinking about it in terms of the Interplanetary Initiative as improving our collective ability to truly understand, responsibly manage, and intentionally sustain planetary scale systems. So beyond the incredible importance of this for our current planets, the notion of being able to think on this scale and manage this stuff of this complexity and this many fields coming together at once as we think about life on other planets. To date, we've finalized a specification document describing the physical space, the actual built environment that will result someday from one of any number of potential possibilities, some of which I'll get into. We've completed a functional interactive virtual reality prototype that we're continuing to add features to and get out into a wider and wider audience. We've tested that prototype with collaborators from multiple fields. And then lately, we've been recognized as a critical step in managing not this project, but not necessarily this project, but the concept of an Earth Operations Center style space has been recognized as a critical step in managing climate change by the World Economic Forum. So this white paper came out just a few months ago, and the Earth Operations Center concept was featured rather prominently. And there was an in-depth discussion about the necessity of having a place where communities, industries, countries, and fields can come together to think about and manage the global systems on a collective level. We also, very shortly thereafter, almost I think like the next day, there was an announcement from the NASA administrator, Senator Nelson, that NASA was going to invest in a similar product. And most of this has been enabled by our NASA partner, Alex McDonald, who is one of the originators of this concept and the chief economist for NASA and serves as an advisor to the World Economic Foundation, so a World Economic Forum. So he was able to take the VR prototype. We sent him an Oculus Quest loaded with the experience and was able to show that to a number of his colleagues in both NASA and WEF. So that's been really nice to see the influence of this. I mean, obviously, this is an idea whose time has come. Whether or not we end up playing a major role in it directly as a project team is yet to be discovered, but it is certainly something where we're at least helping to inform the evolution of this concept. The activities for the rest of this year, we have a series of introductory narratives that we want to build, sort of stories to welcome people into the EOC space in virtual reality and walk them through how both the space works and how the VR interface works. We're conducting a studio class with architecture and interior design students in the spring to flesh out more details about the built environment, the shape of the building, the way the interior spaces can work in the actual built environment for a final product. We're going to be debuting this VR experience at several field conferences and events, toting our suitcase full of headsets. And then we'll be finalizing some external partnerships and development timelines for next steps, and we have some not able to be yet discussed possibilities about potential future built environments and public centers of this activity, which we hope will come to a more public fruition by then. I think there's lots of opportunities for involvement, particularly in external stakeholders. One thing that we're particularly looking at is the use of the VR model that we've built as more than just this purpose specific. So how can we build multiplayer VR environments which enable people to collaborate over long distances in the management of complex projects or systems? So how do you want, if you want your own virtual NASA mission control, maybe we can build that for you as a packageable product. We're also going to be debuting this on the Oculus Quest store, the Earth Operations Center version of this. So it'll be more widely available, and it'd be nice to have people who can help test that around the country, as well as promote it to K through 12 and college level educational programs, so that we're getting this product used as an educational aid in thinking about Earth and Earth systems. I think that's about it. A little faster than I thought, but please, any questions? I'm more than happy to field them.
Thank you so much, Jake. That was efficient. And I love the idea of the virtual mission control as a call to possibly follow up projects, building on what you've done. We do not have any questions in the Q&A. I don't know if any of our panelists have questions, but if not, thank you so much, Jake, really appreciate it. And we will move on to our next project, and that is 5 Senses in Space. And Robert Licamo is going to present. He's an assistant professor at ASU in the School of Arts, Media, and Engineering and the School of Electrical, Computer, and Energy Engineering. And he directs the Meteor Studio, which explores the research and design of software and hardware for augmented reality, virtual reality, mixed reality, and visual computing systems. And so we've been supporting also this project for a few years. Super excited to get the updates from you and your team, Robert.
Cool, thank you. Am I projecting okay?
You're projecting great.
All right, cool. So yeah, this is a team effort. Lauren Gold's a PhD student that works in Meteor Studio with me. Phil Weaver-Stace, as you see on the screen here, is an instructor. Catherine Powell is a research scientist, assistant research scientist on the MassCamZ team working with Jim Bell. Corinne Valentine is journalist extraordinaire for the School of Earth and Space Exploration. Victor Surovec from Makerspace, Judy Lyon, community member and philanthropist, and Sarah McDonald is a creative soul and a student, undergraduate student working with us. And these are actually only some of the team. There's others as well who have been working with us over the years. Generally, 5 Senses in Space, our big question from the origination was, how do we galvanize public and private support for space exploration? And one of the big ways that we wanted to think about doing this differently is by engaging human sensory experiences, so that we can bring this down to not just the scientists, not just those who are working on it day to day, the scientists and engineers, but to everybody, so that we can galvanize support across the board, because that's the only way that big missions can really happen. And so we want to communicate, imagine, and inspire by creating engaging experience around Mars science and other planetary science that lets people connect to space exploration. And so we're putting together research projects, creative endeavors, and engaging people through these sensory experiences. So through the past year, as an update, we've been working on a variety of different Mars science AR/VR software products. These are tools for science communication, education, exploration. We've been shepherding some of that in collaboration with the Learning Futures Immersive Creation Studio into a Dreamscape Mars experience, which was really just a tech demo of exploring what we can do with the Dreamscape platform. I'll talk to you more about that later, but it provides a platform for immersive, interactive narrative experiences. We have a Mars habitat physical simulation, which is a trailer that's built out to simulate what it's like to live and work on Mars. And narrative scenarios that we're developing inside of that tie together with all of the above, the AR/VR stuff as well, to inspire what life would be like working on the surface of Mars. And we're building a smell engine to provide additional sensory interactions as well that are fully programmable and appropriate for to engage people's senses into thinking about what it's like to explore space. So this is kind of the summary. I'll go into these in a little bit more detail. JMARS AR and VR. JMARS is a GIS tool. GIS provides map data in composable ways that you can zoom in, you can find what you want to look for, you can annotate, you can layer. And this JMARS has been under development by the Mars Spaceflight Facility under Dr. Phil Christensen for about 14 years now. It's called JMARS, but it actually indexes data from asteroids, the moon, Venus, you name it. It has like a few pixels that represent Psyche right now. It has Bennu. Bennu's pretty cool, that asteroid, right? But it has a lot of different data in it. And the question was, how do we bring that data down to Earth in a way that people can actually explore this, and not just scientists, but scientists can communicate their science outside as well, and show what it is that they're talking about in a really fun way. And so augmented reality is one of these ways, is that with this app, which you could download if you wanted to scan that QR code there on your iPhone or Android device, you can actually see terrains that planetary scientists have prepared and created. And the planetary scientists can go into JMARS, prepare their terrain, and export it as a QR code, which other people can scan. And so we imagine that this is going to be really useful as a communication tool from scientists to scientists and scientists to general public, for education as well. But it's a very simple process of just generating these experiences, then sharing through these QR codes. We're also working on a VR viewer that allows you to walk and fly around inside of these terrains as well. It actually works as a proof of concept, but we're creating the login infrastructure and the scanning infrastructure for all of that as well. But it's a really fun and engaging product. And the next steps for this are to really see it get used. So through AGU, we have an invited talk at AGU that will be talking with the planetary scientists about this. And we're planning to go to LPSC and make a showing at their poster showcase and things like that, so that we see more use of this, put it in people's hands, and then they can do the outreach effort as well. So yeah, it's a cool tool that we've developed over the years. Then the Mars Metaverse is also to not just take orbital data, but also ground-based data and combine them and integrate them together with spatial data visualization tools that can help with mission planning, but also outreach and education. So it's how do we bring, the data that's coming in from the rovers now that are roving around Mars and taking really great imagery, how do we combine that into these terrain meshes that then we can explore in AR and VR? And so we're building up a lot of partnerships. So the student Lauren Gold, she did an internship at the Jet Propulsion Laboratory this past summer with a place called Data Space with Joe T. Roberts. And so Joe at JPL is working on a lot of data visualization tools and looking at the cutting edge. And so Lauren worked with him on thinking about what would the mission planning tools, how could mission planning be empowered with immersive tools to help them out. And Catherine Powell, who's on our team as an assistant research scientist, she's working on that MassCamZ team with Jim Bell, and Jim has given us his blessing to use the latest MassCamZ data that comes in over the wire and put that together inside of photogrammetry processes for terrain generation. After, of course, they've been cleaned and whatnot, but we get the up-to-date data so that we can be current, we can be up-to-date and really explore the real data in these different forms. Corinne Valentine has been writing a lot of articles about this, and so you've probably been seeing them in the II newsletters and things like that, but all of them usually have Lauren Gold, usually wearing a headset, waving something around in the air. So I'm sure you've seen them, but thank you so much to Corinne for writing those really great articles. We have an invited talk at AGU about these AR and VR products, and we also published some of this work academically as well, like to IEEE VR this past year. And we're doing grant writing as well so that we can raise our own funds and support this. So it's been a really great adventure with II to give us that early seed in order to go after these bigger pots and bigger adventures on our AR and VR products. We also, since the team was also invited to take a look at the Dreamscape software development kit. So Dreamscape is a multi-user VR walkable experience that you get to create using the Unity game engine. And so we wanted to play with their software development kit to actually create new narratives. They have haptics for the rumbling floor and wind that shoots into your face. And so we wanted to just go after a story. And so we leveraged some assets and stories from II's 5 Senses in Space and the team as well. And we partnered with the Learning Futures Immersive Creation Studio, which had artists and animators to fill in narrative assets and programmers to create pod experience. We had sound design as well from film faculty, Rodrigo Moraes. But we basically built out this narrative experience where, sorry, I'm muting it on my end, but we were able to give people the experience of seeing what it's like to watch a rocket launch, see what it's like to be on Mars and watch the rover land on Mars, and pair that with real imagery so people can understand that it is a real thing that humans have done is these endeavors in space exploration. So it's really about bringing these space experiences down to Earth and having people viscerally feel what it's like, which is very much in tune with Five Senses in Space's mission. And we were able to put Jessica into it and Catherine McConaughey. So thank you for being our, pilot astronauts. And I hope you came back okay. So, as you know, we've also been building out this Mars Habitat Unit, this trailer. But because of COVID and because of the lack of ability to take people into physical spaces, we decided to also turn it into a virtual space. And so we actually took a ton of pictures inside and turned this into a photogrammetric 3D mesh model. So that's a static model that you're seeing that we can now actively navigate through and within inside of virtual reality and inside of a desktop browser. Just think of any 3D game. You can now go inside of this and you can see how photorealistic that whole mesh looks as well. So it's a little bit wiggly. It's not perfect, but it gives us a good setting for being able to explore integration with these other AR/VR software tools that we've got, all these other Mars experiences. And we're really looking for that unification through our theatrical narrative. And the theatrical narrative, for those of you who haven't heard of this before, is this hab is supposed to be a place where participants will imagine themselves as future Martian workers and think about what it's like to be mining ice on Mars. So we have a narrative team, a technical team, and the end goal is to run events at ASU and local museums that would be able to showcase all of these amazing products that the students and staff and faculty have been collaborating on. And there's also a smell engine. It works now, which is a development. It produces physical smell representations of virtual odors with varying intensity and composition based on your proximity to different parts of your virtual environment. And we're now considering what kinds of odorants to put through. We have some base odorants that do work really well, but now we're going to look for topic appropriate ones, including with space exploration, so that we can see what it's like to smell on Mars and share what it's like to smell on Mars. It's a big collaborative team. You can read the names there, but it's across multiple different disciplines and faculty and students to make this all work together. And we published there as well. So thank you to II for your support of this project over the years. It's been a long road, but it's been a really good road. So for everybody, we are planning to do an open house at some point. We haven't created all the logistics for them, but we'd like to invite you to our open house or open hab next semester, where we can show off the unification of these different projects and each of the projects in their own entirety as well. But yes, let me know if you have any questions, and you can always reach out. Okay.
Excellent. Thank you so much, Robert. And with the caveat that this was my first Dreamscape experience, so I have nothing to compare it to, but even as a tech demo, I was completely transported and it was incredible. So thank you for that. And hopefully others will have the opportunity to do the same and experience it. We do have one question that came in. How can an online ASU student volunteer on a project like Mars Metaverse?
Well, we actually always need some labor to work on processing the data into these meshes. I was chatting with my student Lauren. It's a lot like fishing. You go out there, you throw your line, and you see what comes back. Sometimes our software is like that. So if you'd like to fish, be a fisher person for us, and go out there and throw the data into this software and see what comes back, we could always use more fishers of data. Just reach out to me. Actually, the answer is reach out to me.
Thank you. Excellent. So there are no more questions. Thank you so much, Robert. That was great. Yep. Great progress too. Awesome. And we'll be coming to visit the hab for sure when you have the open hab. So next, I would like to move on. Now we're going to move on to our new project. So we just selected and started funding these projects. So we're going to be looking to the future on these. And the first is going to be religious space, and Phil Stoa is the team lead. He will be presenting today. Phil is a facilitator, educator, creator who works at the intersection of service and imagination. He's an instructor of interdisciplinary collaboration and critical response, and an instructor for our technological leadership making courses, and also has his fingers in several other pilot projects, which is awesome. And so Phil, thank you so much for presenting today.
Cool. I'm really grateful to present. Okay, let me do this. Let me click a few buttons here. Cool. Can you all see this? Amazing. So I'll start with the big question of this project. which is what is the relationship between space and religion, which is an incredibly broad topic. And we have an incredibly broad scope of what we are looking for. But first, what I'd love to do is take this opportunity to actually do some research right here in this space. So Sally, we have some questions for you all. And I'm wondering if you would be willing to answer some of these just to see what this looks like. Slightly, we have some slightly and moderately, a little extremely. Cool, we'll close the question in about 10 minutes. I'm sorry, 10 seconds. Cool, so it looks like we have a bunch of people across the board. And can you all, hopefully the participants can all see this research that is happening currently in this. Oh, let's share results. Yes, please share the results. Cool, it's a little bell curve. It's beautiful. Let's move on to the next question. How would you characterize the relationship between the religious and spiritual part of you and the scientific or academic part of you? As we're entering into this project, one of the things that we're thinking about is what is the relationship between how you see yourself as a space technician, space engineer, and how do you see your relationship with religion and spirituality? So this is also a sort of present question that we're asking right now. Cool, and these are the results. For a lot of people, they're entwined and inseparable and in conversation. And for a few folks, it looks like 4 folks, that there's conflict between what it looks like to be religious and what it looks like to be scientific or academic. Cool, let's jump to the next question. There are 5 questions in total. I'm really grateful for you all to participating. I'm getting my little research done right now. This is my efficiency of time. Question 3. Now, this is a choose the best response, which is what word describes your relationship to the concept or reality of outer space? And it may be more than one, but choose the best answer. Cool, we can close that poll and share results. Looks like people are mostly fascinated. There's a spiritual person, some people who are fearful and reverent, but awestruck, curious, and fascinated. Cool, let's jump to the next question. How has your relationship with religion changed over your lifetime? Cool, we'll give about 5 more seconds for people to answer. Cool, we can close that question. This is interesting. It looks like most people, the relationship has grown more distant over time. That's a really common narrative. And for some people, it's grown closer. That's really cool. Cool, let's do the last question. I'm really, really excited and really grateful for all of this. I'm gonna be tracking all of this and we can do some of our research. And the last is, how would you characterize the relationship between your religious practice and the work institutions that you are a part of? These could be science spaces, these could be whatever industry you're in, or whatever thing you do and how you show up to work. What is the relationship between that work and religion? Cool, we'll take about 5 more seconds for that question. Cool, and these are the results. Many of you have no religious practice at all. And for some it's neutral, and for a few there is an unfriendly relationship, and for a few it is inseparable between the work that you do and the religious practice. Cool, thank you so much. That was really, really fun. I'm really grateful for all of you to be able to answer some of those things. We can close the poll and I'll go back to presenting now. So I'm gonna give a little bit of context for this project, where it grew, sort of some of the goals and values and deliverables of the project, and talk a little bit about the team. We haven't done anything yet since we are a new project. So there's some of the small picture context for this project. I come from a Mennonite background, and I was always struck by this difference between my Mennonite communalism and what I felt was this academic individualism, this idea of what it means to be an individual in an academic institution and the collective meaning that I grew up with. And there was a time that I went through this idea of only seeing meaning through this emotionless, rigid lens of philosophy and research, that no other meaning entered into my life other than what was researchable, other than what was nameable in this way. And the more I worked, the more that some of my religious friends, mostly Muslim friends, would talk about God really actively in their work. And it started nurturing this idea of what does that mean to be religious and also scientific, religious and also academic. And I know that many, many people have tussled with this question and entered into this space far before I have. And so it brought me to this question, which is how do you be a holistic researcher / artist / human for myself? How do I do research? How do I make art? And how do I be holistic, both in how I understand research and space exploration and space future, and my own spirituality and values that I take in. And every collaborator on this project will have their own personal religious context. So this is sort of a small picture context for what this is. The big picture context is that Interplanetary is pushing for an equitable and accessible space future and what that means. And from my perspective, and in thinking about this, religion and collective spiritual meaning making must be a part of this inclusive space future. That it cannot simply be the architecture, it cannot simply be the sort of rules and laws and patterns. We have to understand what religion and spiritual meaning making looks like in that space. And specifically to progress through this diversity paradigm, how do we see diversity? And when I was growing up, we used this word of tolerance a lot. You tolerate someone who's different than you. And I'm interested in progressing from tolerance through the sense of acceptance, which is great. I'm going to accept you, not just tolerate you. And even moving past acceptance toward a sense of celebration, which is if someone thinks differently, finds different meaning making, has different ideas than you, it can be a celebration and not just something you were trying to tolerate. So these are some contexts around which this project is taking place. So the mission. The mission of this project is to explore the intersection between religious practice and space futures. We're going to gather interviews from ASU and the broader community. We are going to host spaces that are healthy and curious interreligious and scientific spaces about how people do meaning making around ritual, around religion, and what that could look like in our space futures. We're going to gather some past knowledge that has already been there for perhaps dozens or hundreds or thousands of years, and also grow new knowledge about how religion and spirituality and space connect. And we will be expressing our findings through design, through writing, through art, through research, and through many different pathways. So these are some initial values that I'm coming in with. Values of a project are born collectively. So as we begin doing the work, these values might change. But as a lead, I'm coming in with these values, which is creating safety through practicing curiosity. For some folks, religion is a really personal, really vulnerable part of them. And creating safety means practicing curiosity, not a sense of distance, not a sense of attempting to convince, but being able to practice what it looks like to be curious about how other people make meaning. There's also a sense of multiplicity of meaning and knowledge. There are many different ways that we can come to understandings about things. And I have some of my own, and everyone gathered will have some of their own also. I'm interested in emergent research methods and communication style. I have some methodology. There are people on the team who know way more about quantitative or qualitative research than I do. And there are some people who will know more about expressive research or animated research or all sorts of different things. So it's an emergent style of understanding. And also it is a communal project of research and creation. I like to enter rooms as the person with the least amount of knowledge. Even if that's not true, it is the guise I put on so that I can fully understand things. So this is a communal process. And some of the goals, so this will be happening next semester. Some of the goals that we have are a design collection of cosmologies. We're going to do some interviews and transcribe them. We're going to do some story circles where people come together and share stories of the relationship between religion and space, religion and science and technology and all those things. We're going to write a white paper about some of our findings, and we're going to host a gathering wherein people will be able to express some of our findings, both in presentation format and also in some performative and art-making contexts. And then we'll be applying to some conferences to show our work. The team is growing. So this is me and one of my dear friends and colleagues, Munira, who is a designer and religious thinker who works in Pakistan. Some of the folks that have come on, Alexandra helped me actually craft some of the questions that you answered. She is a researcher in social psychology, so she helped me sort of think of some of these questions. Aletta is coming in thinking about designing space colonies and what that looks like. Derek is the CEO of Read the Future and a childhood literacy nonprofit. Indira manages Thunderbird in Chile and Peru. Mrudula, we had a conversation already, which is wonderful. She's a master's student in exploration system design and founded this amazing Instagram thing called Humans of CC, which is a really cool way of interviewing and showing the human side of science researchers. And then Doe, also an instructor in religious hybridity and gender and pop culture. So there's a lot of people who are in the Shippers, which is the School of History, Philosophy, and Religious Studies. I hope I got that right. And those are all the people that I could find headshots of. These are all the people who have contacted me about this project and who are interested in coming on board. So there are undergraduates and graduates, alumni and faculty, as well as community members. I'm having conversations with Mirabella and working professionals, folks who are interested in coming on and having a sort of say in this project and what it will look like. And we have our first meeting on Thursday morning. So if you would like to get involved as a collaborator or funder, you can contact me. This is my email right here. And I'm curious if you all have questions for me or about some of this work. Thank you so much for your time.
Yeah, thank you so much, Phil. This is a really intriguing one. And I'm sure you're going to want to speak with many, many different types of people. And so one of the questions that came up here is, have you thought about a larger cultural anthropological understanding of religion to generate a framework to think about different religions and their conceptions of space?
Yeah, I really love this. I mean, it makes me think about how to understand religion's relationship with how they see space, both historically and currently. And I am curious about this partially because when we all think of space, we can think of it from a scientific context. And also there have been an incredible amount of other creative, religious, spiritual, mythological contexts through which we understand space. And I am a theater maker, so I believe in the power of story. And the stories that we tell about space are important. And the anthropological context from which those come, and also the possible imaginative ways that we can make that is really exciting for me. So creating a framework, that sounds intimidatingly large, but I am excited to think about that. Thank you, Thomas.
Wonderful. Thanks again, Phil.
Cool. Thanks.
That's great. And now I am very pleased to introduce Shaleka Lewis, who will be presenting on also a new project, which is entitled Integrating Space in the Local Economy. Shaleka is a current second-year grad student in the Masters of Global Management program at the Thunderbird School of Global Management with a focus on global business and healthcare delivery. her research interests lie in finding the point where policy, science, innovation, and business interests align to create a better environment and community for present-day individuals and future generations while elevating marginalized perspectives and stakeholders. Shaika, thank you so much for joining us today and presenting on behalf of your team. And we're really excited to learn more about what you have planned for the year.
Well, thank you. I will start sharing my screen. One second. Here we go. So yes, our project is looking at integrating space in the local economy. And where this begins is many times we consider how does space commercialization going to work in the actual realistic world, and just interacting with space. Many times it's considered on the national level. And it is not giving much thought to what does it look like for municipalities, cities, and even states to be also involved in this new ever emerging frontier of space. So that brings us to our research question of what are the governance and economic structures we can use to best integrate space into the local economy? And as being ASU, we'll be using the case of Arizona. So as I was saying before, it's a really important question because you have to consider every tier of governance when you are trying to join and really develop an industry, along with understanding what are the capabilities or what are the different stakeholders that are necessary to be part of the conversation to have and create a successful ecosystem for this development. And so we're trying to deliver a solution to developing and thriving the space sector. And what does that mean at each level of governance so that we can ensure that there aren't state regulations that may conflict with national regulations, that also may conflict with local or even county level regulations when we are trying to support this economic endeavors. So the lessons that are going to be learned from this exploration will really provide insights into just like what is necessary for this really thriving industry and what is necessary for new entrants and current entrants into this industry. So some of our project goals is from right now until February, we're gonna be doing research. We'll be advancing, looking at, like I was saying before, the current stakeholders in Arizona, along with what are the strong economic industries that are currently present in Arizona, along with what are the goals of, let's say, the Greater Phoenix Chamber of Commerce, the Arizona Chamber of Commerce, and see where it can align with the space industry. What are maybe those manufacturing companies or those aerospace industries that are already here and could use additional support in continuing on with joining and being part of the space industry. We'll also be doing an analysis of what are maybe some of those new stakeholders who can also join this industry, because a big part or a big issue that we sometimes see is that many contributors don't know that they're even stakeholders. Like there may be plexiglass companies that don't even realize that they could have a space within the space industry, and it's helping to bring them into this dynamic and give them a seat at the table of understanding where they can also grow in this thriving new sector. After that, we will then hold a stakeholders event and give a real presentation just to showcase what could be and what is already going on with integrating into the space economy. And that would definitely include developing economic models that will help leverage debt and equity and look at different workforce development and or marketplaces where we can have success. Following that, we would then present for additional funding from the Economic Development Authority and developing that grant. And then our final report will be for the Arizona Space Commercialization and Growth Opportunity Plan that articulates the commercial space narrative, along with looking at comparative analysis, the stakeholders that can support this future growth, and the approaches to building this economic growth. And then lastly, from there, we'll then develop an academic paper that will be submitted to the Journal of Economic Innovation and Management, New Space, or New Space Policy Journal. Currently to date, we've had our project team assembled. We've also had our kickoff meeting. We've identified some of our major internal stakeholders, along with looking at what has already been done? What are some municipalities that maybe have already considered looking and working with their either state and national level governance levels? And then also considering what are maybe other researchers who have been looking at varying different areas, either internationally or in other places in the United States as their models. Our team is made up of our project lead, Professor Timmy. We also have a partnership with the Kelis partners and are working with them as they have a large background in industry success and in developing different models. And a lot of times their models have been how to integrate various different industries, such as healthcare or finance, into the space economy within their local areas. And then from the proposed students who are part of this project, we are all graduate students. There's myself, who has a background with global governance from Thunderbird. There's Nulefer, who has a background from economics with WP Carey. Alexandra, who has a finance background from Thunderbird. And then Jonathan, who has a science and technology policy background. And so, yes, if you would like to get involved, either as a collaborator or fundraiser, please reach out to our project lead, Timmy, and I'm open for any questions.
Excellent. Thank you so much, Shalika. And just as a comment here, certainly from the ASU perspective, this report will be very informative and interesting for us to think about how ASU can support from a policy or research, educational perspective to further grow the industry here in Arizona. So this will be very much actionable from an ASU perspective. There is one question for you, Shalika. Is it possible to join this project as an assistant/member?
Yes, I believe there is. You would just have to reach out to Timmy with the email that was provided right there.
Perfect. Yes, thank you for your interest, and certainly reach out. I'm sure there will be opportunity to assist and support. Again, thank you so much, Shalika, and we'll move on to the next and final project report. And so this will be presented by Eric Stribling, who will be presenting on space exploration and sustainable development. Eric is an instructional professional with the Interplanetary Initiative, where he teaches an online making course for the Technological Leadership Program, which you heard about briefly in Lindy's introductory remarks. He is also a professor of mechanical engineering at the University de Montagne in Cameroon. And he's currently pursuing his PhD in global development at ASU, where he focuses on the role of engineering in addressing societal goals in the global South. So we're really thankful, Eric, for you to take the lead on this project, which is such an important topic. And it's all yours.
Thank you so much. All right, let me just share my screen. And okay. Hello, everyone. My name is Eric Stribling, and I am here to present our project, Space Exploration and Sustainable Development. So our primary question with this project that we're seeking is, how does space exploration intersect with the Sustainable Development Goals? And sort of start off this and introduce this project, I sort of want to start with a metaphor. So in trying to answer the question of extraterrestrial exploration for terrestrial life, easy to look at this sort of moment that we are about to go, hopefully, explore outer space and think about some of the other the other moment when mankind, or humankind, went and explored the world, and it was sort of followed by this period of colonialism, slavery, genocide. But in exploring, outer space, where I think that it might bring to mind a more of a similarity with our period of Antarctic exploration. So this is a photo here of Robert Falcon Scott's exploration, his party that went to discover the South Pole. And maybe some of you have heard of this story, but he set out to plant the British flag at the South Pole with this team here at Wright. However, at some moment, they start to run short of supplies. They start to realize that it might not be possible, but they decide that, you know, they're going to explore at all costs. And essentially they did reach the South Pole. They did plant the flag there, and then on the return journey, all 5 members of this team died. So it sort of just makes you think that at a certain moment, we have to think about societal implications of what we are doing. And exploration is not always synonymous with societal benefit. Nor is, you know, going into space always usually brings with it a lot of technology that we need in order to live in outer space. And I think as we are seeing, there's actually a wonderful article that just got published in Issues in Science and Technology, which is Shining a Light on Our Innovations by Anissa Ramirez, where she talks about how even though we see the blue LED as one of the most important discoveries, it actually won a Nobel Prize in the last, recent years. The blue LED has not necessarily had 100% positive benefits. It has had negative repercussions on elderly driving, on our ability to go to sleep at night. So, all of our technologies have embedded values, they have consequences, and as we go forward, it would be very, this brings up this question of what space exploration might do for the rest of us left here on Earth. So the mission of this project is to look at our global future and its intersection with space exploration, and we use the United Nations Sustainable Development Goals as a framework towards addressing those environmental, social, and governance impacts. And the United Nations goals sort of offer, they are sometimes in contradiction with one another. The next slide actually shows the 17 goals that the UN has proposed as places that we, all nations, all peoples can go towards together. So hopefully we can, for example, number 1 is to eliminate poverty. Number 16 is for peace and justice worldwide. So this, even though some of these might be in conflict, for example, economic growth, number 8, may not necessarily be always in line with number 13, which is climate action. But at the same time, these are all goals that we can sort of go towards together. So this project envisions, it's built into 3 stages. So the first stage is research. We plan on building a research team, a 5-person research team that will go and conduct a comprehensive, systematic literature review of each one of these SDGs individually and its intersection with space exploration, to sort of give us a comprehensive map of the state of the literature. Then we want to eventually bridge into practical application. And the way that this project envisions practical application is by developing ESG benchmarking for corporations, so that these findings, these aspirations that we discover during our research can be put into action through frameworks of corporate social responsibility. So hopefully this can help inform business practice in the burgeoning space industry. And finally, we envision for this particular project a moment of public engagement where we can sort of present out to the ASU community and to stakeholders worldwide the findings of our research. For the practical application, just to bring it back for a second, we are actually going to be working primarily during this semester because this is taking place during the spring semester. We want to work on a grant proposal so that this practical application step can take place. So our project timeline here, we are currently building out the team. So actually, if you have any undergraduates or a graduate research assistant who might be interested in this project, we are currently taking applications for roles in our team. During the spring semester, the undergraduate researchers will conduct literature reviews, as I stated previously, into each undergraduate. So we have 4 undergraduates, each will take 4 sustainable development goals and sort of look at those goals in isolation and its intersection with space exploration. And then the research assistant will largely work on synthesizing those findings together to sort of create a comprehensive whole that reviews the entire academic research field. Then in May, we will have a public presentation of the findings, and June and beyond in the future, we hope to apply this research in a corporate setting, specifically within the space industry. Who are we? So we first have Diana, and Diana actually wrote a book on the SDGs. She spent a large proportion of her academic career researching into these ideas of global goals. Myself, I am currently pursuing a PhD in global development, and I do teach engineering in Cameroon. Ryan Johnson is also here, and he is an executive director within the School of Sustainability. Very interested in these questions. And finally, Jonathan Roll, who is a master's student in science and technology policy, focused on ideas of space governance. So certainly if you would like to be involved, I would love for you to shoot me an email, and thank you so much.
Excellent. Thank you so much, Eric. We don't have any questions coming in at the moment, but really excited about this project. And certainly if there are any external partners that might want to collaborate with us, we're very much ready to get this project going. And I believe that Lindy probably is not going to be able to close us out, unfortunately. So on her behalf, I want to thank everyone who joined us today for this webinar, and it will be available online, of course, and also thank you to all the presenters for participating and sharing all of your updates. And we're doing these every 6 months now, so please stay tuned for our progress, which we'll be reporting out over the summer. And I believe we do have one final poll to ask you all to indulge us in, and please respond to. This really helps us craft these updates in a way that delivers the most value to all of you, to make sure that we understand our audience and that we're sharing pertinent subject matter. So thank you so much for participating in this final poll, and thank you for tuning in with us today. Looks like there's still some entries, so I will wait. Looks like we might have one final question, so I'll also hang tight for that as well. Awesome. Do we have to? Okay, I think for the results, as long as we have them on our end. Great. Thank you so much for participating. Thank you all so much for joining us today, and we'll see you in 6 months for the next one. Thank you.